Welcome to this engineering guide on electrical cable tray systems. This video covers the essentials, including system types, sizing, safety, installation, and applicable standards like IEC 61537 and NEMA 5E1. Here is the table of contents for the video, covering 18 key topics, from cable tray overview and types to system components, routing, fire protection, and quality assurance. A cable tray is a structural system for supporting and routing electrical cables, control wiring, and fiber optics in various installations, compliant with major international standards. The common types include ladder, perforated, solid bottom, wire mesh, ventilated trough, and channel/duct trays, each suited for different applications based on ventilation needs, load capacity, and cable type. This slide outlines the essential international standards, codes, and regulatory frameworks governing cable tray systems, including their dimensioning, performance, installation requirements, and safety features. Key standards covered are IEC 61537, NEMA 5E1, BSEN 61537, and NFPA 70. Cable tray material selection is crucial for performance and longevity. Options include hot dip galvanized steel for C3 environments, stainless steel 316L for high corrosion areas, and aluminum alloy 6063-6080 seconds for lightweight structures. Other options are PVC GRP for chemical resistance, pre-galvanized for indoor use, and powder-coated for added protection. The sizing methodology involves 8 key steps, starting with listing cable data, summing the cross-sectional area, and applying the required fill factor. The required tray width is calculated based on the total cable, cross-sectional area, and fill factor. Final steps include load checks, derating for stacked cables, selecting a standard width, and documentation. Cable tray systems consist of various components to manage cable routes. These include straight sections, horizontal bends, T-pieces, cross pieces, reducers, and vertical risers/drops for direction changes. Accessories like end caps, splice plates/couplers, and riser clamps are also essential for proper installation, mechanical continuity, and safety. Support spacing and structural design are critical. Common support types are unistrut/strut channel, trapeze hangers, and cantilever/wall brackets with specific load limits and span capabilities. For seismic zones, compliance with IBC/ASCE 7 or IEC 6006833 is required, demanding stringent bracing intervals and cable clamps. Cable tray route engineering follows a logical progression, from identifying cable origins and destinations to plotting the route on a floor plan. Key design principles include checking clearances, determining tray widths and depths, designing the support system, and issuing route drawings. Considerations for horizontal and vertical routing, bend radius, and future capacity are essential, often requiring BIM/3D modeling. Mandatory segregation requirements, per IEC 61537, govern the separation and spacing of different cable systems like HV and LV power, control, and data. The minimum separation distance varies depending on the system type. Where physical separation is not possible, solid metal barriers or shielded tray sections are necessary. Cable tray earthing and bonding requirements ensure safety and system continuity. A low-impedance continuous earth path must be provided, with proper sizing of the protective conductor cross-sectional area. Earthing clamps and straps are used at joints, and all metallic components must be bonded to the structural earth grid. Continuity testing and specific requirements for EX/ATEX installations are also detailed. Cable fire performance is a life safety issue governed by standards like IEC 60332 and NFPA 70. Fire barriers are required at penetrations to maintain fire resistance ratings. We also cover cable fire rating categories, the use of fire-rated trays for circuit integrity, mineral insulated cable for critical circuits, intumescent coatings, and fire zone separation strategies. This installation process outlines best practices across 6 phases: survey, fabrication, supports, tray erect, cable pull, and finish. Key practices include site walkdowns, workshop fabrication with touch-up painting, correct torque application on supports, proper splice plate bolting, maintaining bend radius during cable pulling, and final labeling and inspection. The Inspection and Test Plan, or ITP, ensures quality assurance for the cable tray system. Activities range from checking material receiving certifications and visual inspection of labeling, to precision measurement of support installation and electrical testing of earthing continuity. For hazardous areas, ATEX/IECEX cable tray requirements are mandatory and depend on the gas/dust zone. Zone 0/20 requires sealed conduit or XE armored cable only. Zone 1/21 requires solid bottom covered trays and equipotential bonding every 10 meters. Zone 2/22 allows ladder or perforated trays with bonding every 20 meters, while safe areas follow standard IEC 61537 rules. This slide covers ATEX/IECEX cable tray requirements for hazardous areas, focusing on cable selection, earthing, ingress protection, and essential documentation. Cable selection is governed by IEC 6007914, requiring LSZH armored cables and certified XE or XD cables. All exposed metalwork must be bonded to the EBB with a resistance of less than or equal to 1 ohm. Corrosion protection is determined by the environment class, following ISO 12944 and IEC 61537. We classify environments from C1 indoor dry to CX extreme petrochemical. Recommended finishes range from pre-galvanized steel for C1 to stainless steel, or GRP/FRP for the most corrosive C5 and CX environments. Annual inspections are recommended for C4 and C5 areas. For electrical substations, cable management is specific to trenches, MVHV runs, and control cables. Trench trays require ventilation and SS316L supports. MVHV runs need a minimum 300 mm separation from LV/control. Control cables use shielded twisted pair on solid bottom trays, bonded at one end only for EMC compliance. Sustainable cable tray practices, or green engineering, focus on recyclable materials, LSZH compatibility, and waste reduction. Recycled content is prioritized, and materials like GRP are managed for end of life. We use solvent-free coatings and minimize waste through prefabrication and zero-wrap delivery. We also look at carbon footprint data to select suitable materials. The project lifecycle includes feed, detailed design, procure, install, commissioning, and operations and maintenance. Key deliverables, such as the cable management philosophy, cable schedules, layout drawings, and inspection records, are necessary throughout these phases to ensure system quality and compliance. Thank you for viewing this video on electrical cable tray engineering. For more content on tray types, sizing, standards, fire safety, and green engineering, please like, share, and subscribe to our channel.